In this video, I'm going to prove this interesting inequality where k and n are both positive integers. And then we have k over n plus k strictly less than log of 1 plus k over n is strictly less than k over n. And then we're going to use this lemma and that lemma. And so previously, in my previous video, I've already proven that the left-hand side as a sequence is a monotonically strictly increasing sequence that approaches e as n approaches infinity, and the right-hand side is also a sequence that's monotonically strictly decreasing approaches e as n approaches infinity. And we're going to also use this lemma. This lemma can be directly derived from this lemma, right? And this lemma simply can be proven true because, like I said, left-hand side is a monotonically increasing, therefore it's obviously less than e. And the right-hand side, as I proven in my previous video, is monotonically decreasing, therefore it's in fact easily strictly larger than e. And from this fact, we can easily take the logarithm on both sides, including the middle side. And log of e, right? So log of e is simply 1. So I have 1 here. The left-hand side, log of this quantity becomes, take down the power, right? So n times log of 1 plus 1 over n. The right-hand side, the logarithm, right? Take down the power to the front. So n plus 1 times log of 1 plus 1 over n. And now simply I can just use the left-hand side of the inequality, divide everything by n, right? So log divided by n becomes log itself. And this side becomes 1 over n. So I have log of 1 plus 1 over n is strictly less than 1 over n. And on left-hand side is strictly larger than right-hand side. I just need to divide everything by n plus 1, right? So 1 over n plus 1, right? Strictly less than log of this thing. So this is in fact also true, right? So this is true, that is true. And then we're going to use this fact to prove our inequality of it. And first of all, I want to rewrite 1 plus k over n. So 1 plus k over n can be written as common denominator n, then n plus k. And that can be written into n plus 1. Times n plus 1, n plus 2, right? Times n plus 2, n plus 3, times all the way up to, on the top is n plus k. The bottom is n plus k minus 1. And so n plus 1 cancel. N plus 2, n plus 2 cancel. Cancel, cancel, cancel. And this bottom cancel with the previous top. So in the end, I have n at the bottom and n plus k at the top, right? The same thing. This is a very common technique, a useful common technique. I'm going to use it very often in my future videos. I'm not just dealing with this type of problem, but many other types of problem. I'll be using this technique, right? And so therefore log of 1 plus k over n can be written as log of this quantity. Log of this quantity can be split up into the sum of logarithm, right? Logarithm rule. So therefore log of 1 plus k over n can be written as log of this quantity. And this quantity is in fact split up the top is 1 plus 1 over n, 1 plus 1 over n, plus log of the next quantity can be split up into n plus 1 plus 1. 1 plus 1 over n plus 1. And next one is log of this thing. 1 plus 1 over n plus 2, obviously. And plus all the way up to log of this thing. This thing is simply split up into 1 plus 1 over n plus k minus 1. Right? Similar, same pattern. Right? So bottom, same bottom, 1 plus, no problem. And now, to reach this inequality, I have to use this quantity, right? Analyze each and a single one of them, right? For example, the first one, what relation does it have? The first logarithm, I already shown that using this lemma, right? I've already shown that. So in fact, I have logarithm of 1 plus 1 over n is larger than 1 over n larger than 1 over n plus 1. Next one, log of this thing. So log of 1 plus 1 over n plus 1. Strictly less than 1 over n plus 1, right? Same pattern. N plus 1, n plus 1. Larger than 1 over n plus 2, right? This bottom just need to add on 1 here. So likewise, all the way up to logarithm of 1 plus 1 over n minus k, plus k, minus 1. That is less than 1 over n plus k, minus 1. Larger than 1 over n plus k, minus 1 plus 1, right? Okay, so just add them together. Add them all up, right? Is this quantity equal to that quantity? So in fact, now I have logarithm of, I'll just clear up the board. Right, I've just shown that we have a bunch of inequalities. Just add them all up equals left-hand side, right? Inequality remains true. And so now I have log of 1 plus k over n is strictly less than this plus that plus all the way to that. So 1 over n plus 1 over n plus 1 all the way up to 1 over n plus k minus 1. Okay, left-hand side, strictly larger than this plus that plus all the way to that. So 1 over n plus 1 plus 1 over n plus 2 all the way up to 1 over n plus k. Okay. And we're not there yet, but to reach these results, I have to loosen the inequality a little bit. Right, left-hand side, for example, I can let me just say the left-hand side, right? So left-hand side, how can I loosen it a little bit? So left-hand side, I want to make it even smaller. So I want to make it larger, right? I want to, that direction, I want to make it larger than something, right? So that something is smaller than that and smaller than this. Hopefully that something is this thing. So I want to make it a little bit larger. How can I make it a little bit smaller? Shrink it a little bit. To make it smaller, I have to maybe make the denominator a little bit larger. Right? Since it's a reciprocal. Therefore, I can replace n plus 1 with n plus k. Right? So larger than or equal to 1 over n plus k. Right? Also replace this with that n plus k. K could be 1, right? In that case, I have equal sign. But if k is larger than 1, all the way up to k, replace everything, 1, 2, 3, 4, all the way, replace it with k. Then that way, definitely it's smaller since the denominator is larger. Plus all the way up to the last item, 1 over n plus k. How many of them? 1, 2, 3, 4, k of them, right? So just k times this quantity, k over n plus k. Now this is exactly the left-hand side, right? This left-hand side. So that means we just need to loosen the right-hand side a little bit, right? Make it a little bit larger, right? So right-hand side. Make it a little bit larger, right? So this direction. So to make it a little bit larger, I have to replace make the denominator even smaller. Right? Simply replace this denominator by n, and all the way up to this denominator replaced by n, so the denominator is smaller, so the whole thing is larger. Right? 1 over n plus 1 over n, 1 over n, how many of them? 1, 2, 3, 4, 5. If we start from 1, then we have k minus 1. Since we have one more item here, so we have k. So k of them, k times 1 over n. All right, so that is my right-hand side. So indeed, I've shown that logarithm of 1 plus k over n is larger, strictly larger than this, strictly less than that. Also notice that this is only a rough estimate of logarithm. And in a future video, I will be using integrals to reach a more accurate, precise estimate in order to help us to prove Stirling formula.